Welcome to Mathematics 101. We bring the classroom to you. Wherever you are, we'll solve it together. I'm Coach Mack, and we're simplifying fractions today. So, before we get started, let's go over a few key words that we need to know to be able to do this. First, your numerator. That's always going to be the top number of your fraction. Second is your denominator. That's always going to be the bottom. So when I talk about the numerator, I'm always talking the top number. Denominator, always going to be on the bottom. We're also going to talk about factors. Factors are the number that divides another number evenly. Simply put, it's the numbers we have to multiply up to get the bigger number. So let's start with some basic ones. 3 over 6. We can easily see that 3 is 1 times 3. I want to see if there's another factor, 3, that I can get with 6. I can take 2, multiply that by 3, and I'm going to get 6. So to recap our vocab, our factors of 3 would be 1 and 3 because they're two numbers that evenly divide 3. Factors of 6 would be 2 and 3 because they're two numbers that evenly divide 3. When simplifying fractions, I don't want any factor, I want my greatest common factor, which is the biggest number that divides both my numerator and my denominator. In this situation, that number is 3. Because I have a 3 in my numerator and a 3 is a factor for my denominator, they will cancel each other out. And what I am left with is the 1 factor of my numerator and the 2 factor of my denominator. So that means that 3 over 6 can be simplified to 1 over 2, or 1/2. We can do the same thing with a different fraction. Now, of course I can do 1 times 15, but 15 doesn't make sense as a factor for 25. So let's try to break it down a little bit more. The first combination I think of is 3 times 5. I can't divide 25 by 3, but I can divide it by 5. 5 times 5 is our 25. Once again, my factors for my numerator, my top number, are 3 and 5 because I can evenly divide 15 by 3 or 5. The factors for my denominator, 25, are 5 and 5 because I can evenly divide 25 by 5. The greatest common factor shared between my numerator and my denominator would be this 5 because that's the biggest number they have in common. Because they're one on the top and one on the bottom, they're going to cancel each other out. A thing to remember is fractions are division. So we're dividing 3 by 3 here and canceling out. We're dividing 5 by 5 and canceling them out. What that leaves me with is 3/5. So to simplify 15 over 25, I factor them, eliminate their greatest common factor, and I have 3 over 5. Another one that we could simplify would be something like 63 over 81. Here, I know that 63 is a multiple of 9, so that means 9 would be one of its factors. 7 times 9 is 63. When it comes to 81, 9 times 9 is 81. My numerator, 63, can be evenly divided by 7 and 9. So the factors of my numerator are 7 and 9. My denominator, 81, can evenly be divided by 9 and 9. So my factors for my denominator are 9 and 9. The greatest common factor, the biggest number that the numerator and the denominator share, is my 9. Because fractions are division, 9 divided by 9 cancels each other out. And I am left with 7 over 9. Now the ones that we've talked about so far have been multiples that we relatively quickly remember. The things that we learned when we first learned our times tables. But what happens when that number is not so easy? when it's not apparent what you would do to divide. Let's use the example of 72 over 96. If we're struggling to see what number we should divide these by, then what we can do is called prime factorization. So back to our vocab. A prime number is a number that can only be divided evenly by 1 and itself. Our common primes that we can think of are 2, 3, 5, 7, 11, 13, and so on and so forth. All of those numbers do not have factors other than 1 and themselves. Prime factorization, simply put, is breaking a number into all of its primes. All of the little prime numbers we have to multiply up to get our big number. So we'll start by factoring our numerator. 72 is an even number. So the first thing I'm going to divide it by is a 2. When I divide 72 by 2, 2 fits into my 7 3 times. That leaves me with 12. 2 fits in 6 times. I circled the 2 because it's prime, but I'm not going to circle my 36 because I can still split that. Some of us might see that it's an even number and want to divide by 2 again. Others might see that it's 2 numbers that have a 3 and try to divide by 3. Either one works. The order of your prime factorization is based off of what makes sense to you and what you see first. I like to stick to evens, so I'm going to divide it by 2 again. 2 fits into 3 1 time, and then 2 fits into 16 8 times. I can divide by 2 again. Now, when I divide by 2, I'm going to circle it, and I have 9. I'm not going to circle my 9, just like I didn't circle my 18 or my 36, because I can split that again into 3 and 3. Now I've gotten to the end of every branch on this tree. So, 72 is the same as 2 times 2 times 2 times 3 times 3. So let's see what we get when we do our 96. Again, 96 is even, and I like to stick to evens first. But if you saw 2 numbers that can be easily divided by 3, then go ahead and do 3's first. 2 fits into 9 4 times, and then there's 16, which it fits in 8. 2 fits into 48. Again, we're not circling it because we can still divide it, and we get 24. 2 goes into my 24. And I get 12. 2 and 6 make 12. And I'm left with a 2 and a 3. Again, we're breaking it into all of its primes. And what's special about a prime is it can only be divided by 1 in itself. So if we can divide it by another number, you gotta keep going. I can rewrite 96 as 2 times 2 times 2 times 2 times 2, and then lastly times 3. Once again, it's important to remember, fractions are just division. So when we divide something by itself, they cancel out. Every time I have a 2 on the bottom and on the top, they cancel out. So this first 2 will cancel out. My second 2's will cancel out. My third 2's will cancel out. I have no more 2's left on the top, so these are safe. I do have a 3 on the top and a 3 on the bottom. What this leaves me with is a 3 on the top as my numerator and 2 times 2 on the bottom. 2 times 2 is 4. So because I factored out my 72 and my 96, I can clearly see that 72 over 96 is the same as 3 over 4. All right, let's do one more to seal it in. And this time, let's go into the triple digits. We'll do scary numbers. 117 over 135. I don't know about you, but I can't easily decide exactly what the greatest common factor of this is or how to easily split them up. So let's start with our numerator and do our prime factorization to figure out all the primes that we can multiply up to get 117. Now some of us who know their prime numbers pretty well can remember that 17 is a prime number, but 117 is not. A tip to keep in mind: if we add all of our digits and we get a number that is a multiple of 3 or can be factored by 3, then your original number can be factored by 3. So for example, 1 plus 1 is 2, plus 7 is 9. So because when I add the digits up, I get a 9, and 9 can be divided by 3, I know this number has to be divisible by 3 as well. So that's where I'm going to start, with my 3. 3 will fit into the 11 9 times, and that will leave me with a remainder of 27, which is another 3. Let's do a slightly more difficult one. Now we're going to work with 3-digit numbers. Let's do 117 over 135. I don't know about you, but I don't know the greatest common factor for these two off the top of my head. So let's prime factorization these, and then we'll know. Some of us who are really good with our prime numbers will remember that 17 is a prime number, but 117 is not. A trick to finding out if a number is divisible by 3 is to add up its digits. 1 plus 1 plus 7 gives me a 9. 9 is divisible by 3. That means 117 has to be as well. So let's start there. And we'll divide it by 3. 3 can fit into 11 3 times. And that would leave us with 27. 3 can fit into 27 9 times. So we're left with a 39. We can divide 39 by 3. 3 goes into 3 once, 3 goes into 9 3 times, and we're left with 13. Now before we kept breaking down into smaller and smaller numbers, but 13's prime, and so we're stuck here. Now let's go to our 135. So 135, we see that there's a 5 at the end. But you know what? Let's check to see if it's divisible by 3. 1 plus 3 is 4, plus 5 is 9. So, because 135, the digits add up to 9, I know that this has to be divisible by 3. We'll start there. When I divide by 3, 3 can fit into that first part 4 times, leaving me with a remainder of 15, which it can fit into 5. All right, 45. We know that is 5 times 9. And 9 is 3 times 3. If you wanted to, you could have kept going with the 3's. Again, the order of your prime factorization does not matter. I can say that 117 is the same as 3 times 3 times 13. And I can say that 135 is 3 times 5 times 3 times 3. I wrote it this way on purpose. We can easily see that the first two 3's cancel. Now, just because underneath this 3 is a 5, doesn't mean that these 3's here and here can't go together. These 3's will cancel as well. What that leaves me up top is a 13 and 5 times 3. 5 times 3 is 15. So 117 over 35 is the same as 13 over 15. Thank you for joining us to learn about our simplifying fractions, and I look forward to seeing you at our next lesson.